was going through the mall the other day and I saw somebody wearing this shirt, and it said, "Another day has passed and I didn't use algebra once." And I couldn't help but chuckle a little bit. Like I thought at first it was pretty funny, but then I thought about it, and it actually made me realize that that person who was wearing the shirt didn't understand what algebra actually is. When we are solving equations, especially when we get into high-level equations, people think that just because you're not writing out the equation, something like 2x plus 3 equals 11, they assume that because you're not going to write out that equation, that you're not using algebra in the real world. And the reality is that all of us solve problems like this. I want to buy a new TV, and I have a certain amount of money, and I save this much money per week. When we are solving that problem, what we're really doing is creating an equation and solving it, which is what algebra really is. So as we start solving some of these problems, I want you to be thinking about not just the problem itself, but what is the algebra behind it that you're going to be using in the real world. So let's look at that equation first. 2x plus 3 equals 11. And the goal of this problem is to find a value of x so that we end up creating a true statement at the end of the equation. So something equals 11. Now, the way that we solve this problem is just like we were doing with the one-step equations. We are trying to create a true statement by getting x alone. Our last step should be 1x equals something. In order to get 1x, we want to look at the side the x is on and ask ourselves what number is the farthest away from x. In this case, it's positive 3. In order to get rid of positive 3, we have to do the opposite of positive 3, which is negative 3. And we do that because we want these values to be equal to 0 to get rid of them. But by rule, when we're working with equations, whatever we do to the left side has to be done equivalently to the right side. So we are going to subtract 3 from the right side as well. Now we're going to reset our equation and see what we have left. Now on the left side, we got rid of this value and are left with 2x, or 2 times x. On the right side, we have 11 minus 3, and we are left with 8. We have not changed the equation. This is still the same equation we started with, except now we are one step closer to getting x by itself, or 1x by itself. Once again, we ask ourselves, what is on the same side of the x, which in this case is 2, and we do what is 2 doing to the x. In this case, it's multiplying, so we are going to divide both sides by 2, because 2 divided by 2 is equal to 1, or 1x. Then on the right side, we have 8 divided by 2, which is equal to 4, and we now have what we are hoping for our equation at the beginning. Now, the important part here is that you always have to check your answer. And if you come up to Mr. Schmidt right now and tell him you must always check your answer with linear equations, he will give you 5 SPs. So in order to check our answer, all we're going to do is we're going to plug our value of x into the original equation and see if it makes a true or false statement. In this case, I'm going to do 2 times x, which is now 4, and then I'm going to add 3 to both, or add 3 to this, and we're hoping that it's equal to 11 when we're done. 2 times 4 is 8. 8 plus 3 is equal to 11. Therefore, 11 equals 11, and we have a true statement, which means our answer must be 4. As we start working with these problems, they do get a little bit harder right away. Once again, though, we are going to draw our line down our equal sign to make sure that we understand we have to do something to one side and the other side of the equation to keep it balanced. In this case, once again, we find our variable, which this time is y, and we ask ourselves, what is farthest away from y, but still on the left side? In this case, that is negative 6. The opposite of negative 6 is positive 6, so we're going to add 6 to both sides of the equation. The reason why we do that is because negative 6 and positive 6 together is equal to 0. Our left side of our equation only has negative 4y left, and the right side of our equation only has 20. Now, our next step, we're going to ask ourselves, what is negative 4 and y doing to each other? They're multiplying, so we are going to divide both sides by negative 4. Negative 4 divided by negative 4 is equal to positive 1y. The right side of our equation is equal to negative 5. Because we have y by itself, now we're going to check our answer and see if we're true. Negative 4 times negative 5, because that's our y value, minus 6 is equal to 14. Negative 4 times negative 5 is positive 20. Positive 20 minus 6 is equal to 14. Therefore, our equation is true, and our answer must be negative 5. The beauty of checking your answer is the chances of checking an answer and still being wrong is very, very slim. Let's do one more problem that gets a little bit harder. Once again, we're going to draw our line down our equal sign, and we ask ourselves what number is the farthest away from our variable, which in this case is m. Negative 5 is farthest away, and the opposite of negative 5 is positive 5. Whoops, that looks a little ugly, but it ended up working out. Negative 5 divided by, or negative 5 plus positive 5 is 0, and negative 12 plus 5 is negative 7. I now have m divided by 3 equals negative 7. Now this time, the m and the 3 are dividing. The opposite of dividing by 3 is multiplying by 3. So I'm going to multiply both sides by 3. This becomes m, or 1m. Negative 7 times 3 is negative 21. So 1m equals negative 21. Just like before, we're going to check our answer. I get negative 21 divided by 3 minus 5. And we're hoping this equals negative 12. Negative 21 divided by 3 is negative 7. Negative 7 minus 5 more is negative 12. Therefore, we must be correct. Now, before we finish, let's go back to the original question that we had. I have $150 saved up. The TV costs $1,000. If I save $18 per week, how many weeks will it take to get the TV? So this is still an equation problem, even if you don't write out the equation. The way we would solve it is we need to figure out if we have $1,000 now, or we need $1,000, but we have $150 now, what total is left? And the truth is we have $850 left to get. And the question we want is how many weeks will it take to get that amount of money? So $18 is 1 week, $36 would be 2 weeks, and so on. So that sounds like we need to do 850 divided by 16. 850 divided by 16 is going to be 53 and 125 thousandths, which means we can't get part of a week, so it will take about 54 weeks, because you can't stop at 53 weeks, it'd be too short, to get the TV. Now, you're thinking, well, I didn't write out the equation, but this is still linear equations. This is still solving an equation. This is still algebra. If I'm solving this equation, what I really did is I did 18 times the weeks plus $150 is equal to 1,000. And my W was equal to 53 and 125 thousandths. Even though you didn't have to write out the equation, you're still doing linear algebra. As always, if you have questions, please let me know.